Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC, P16F4, indicates an issue with the starter cut relay 2 control circuit, specifically a low voltage condition. This system is crucial for the engine starting function, as it ensures that the starter motor receives the necessary power to initiate engine operation. The starter cut relay 2 is located in the auxiliary underhood fuse/relay box of your Honda Pilot. This relay acts as a switch that connects the power from the ignition switch to the starter motor when the ignition is turned on and the vehicle is in the correct gear selection. Troubleshooting this DTC is essential to ensure reliability and performance in starting the engine, and mechanics should be familiar with the routines for diagnosing issues with relays, wires, and other components in the starting system. In this guide, we will follow a structured troubleshooting process to identify and fix the issue. The DTC P16F4 specifically points to issues related to the starter cut relay 2. This relay is part of the starter control system, which governs the power supply to the starter motor. When the ignition key is turned, the relay closes and allows electrical current to flow, enabling the starter to engage and crank the engine. If there's a low voltage condition in the control circuit, this process may be disrupted, preventing the engine from starting. The starter cut relay 2 is located in the auxiliary underhood fuse/relay box, which is easily accessible for troubleshooting and repairs. This location is essential as it connects various components, including the powertrain control module, PCM, that are pivotal for the starting system to function properly. Several factors can cause DTC P16F4. First, a poor electrical connection could result from corroded terminals or loose wiring that impedes proper voltage flow. Second, a shorted wire in the STRLY2 line can create a low voltage scenario, making it impossible to energize the starter cut relay effectively. Additionally, a blown fuse, specifically the 7.5 amp fuse number C31, located in the under-dash fuse/relay box, can interrupt the circuit, leading to the same low voltage condition. Lastly, a malfunctioning powertrain control module, PCM, which manages the operation of the starter system, may also be the root cause if it is unable to send the appropriate signals to the relay. Each of these scenarios must be investigated to appropriately address the P16F4 code. When dealing with DTC P16F4, the most prominent symptom is an inability to start the engine. The vehicle may exhibit intermittent starting issues, leaving the driver uncertain about when the engine will crank. In many cases, the check engine light will also illuminate on the dashboard, indicating that a diagnostic trouble code has been stored in the system. These symptoms can lead to frustration and inconvenience, especially if the vehicle fails to start unexpectedly. It's crucial for owners to recognize these signs early and report them during diagnostics, enabling a more efficient troubleshooting process. Noticing these symptoms promptly can help in avoiding further complications, ensuring that the vehicle remains operational for daily use. The first step in troubleshooting DTC P16F4 involves performing an engine starting check. You should attempt to start the vehicle to determine whether the engine will turn over or not. If the engine starts successfully, this indicates that the issue might not be with the starter cut relay 2 itself, and you should proceed to the next step to validate the problem. It's important to note that sometimes electrical issues can be intermittent, so clear and confirm the DTC using the Honda Diagnostic System, HDS, before moving forward. If the engine does not start, it is essential to follow the troubleshooting flow to diagnose further and identify if the culprit lies within the starter cut relay circuit or another component of the starting system. In this step, you will turn the vehicle to off lock mode and then to the on mode. It's critical to clear the DTC using the Honda Diagnostic System, HDS, which allows the system to reset any stored trouble codes. Once the DTC is cleared, it's important to check for any pending or confirmed DTCs once again. This step is crucial in determining if the issue is currently active or if it has resolved itself. If DTC P16F4 appears again, it indicates that the problem is ongoing, and troubleshooting should continue to locate the source of the low voltage issue. However, if no DTCs are present, it may suggest that the problem could be intermittent, and it's a good idea to verify all connections to ensure everything is secure. For the third step, you need to perform a shorted wire check on the STRLY2 line. Begin by turning the vehicle to the off lock mode and removing the starter cut relay 2 from the auxiliary underhood fuse/relay box. To do this properly, jump the SCS line with the HDS and wait for more than 1 minute. After this, you will disconnect the PCM connector A51P and check for continuity between two specified test points. The first test point will be pin number 4 on the PCM connector, and the second will be a body ground. Continuity here will confirm whether or not there is a short in the STRLY2 wire connecting the PCM to the starter cut relay 2. If continuity is present, you will need to consider repairing the shorted wire. If no continuity is found, this indicates that the wire is intact and that the investigation should move to the next step. In this step, you must perform a starter system check to further evaluate any issues related to the starter cut relay 2. Start with the vehicle in the on mode and shift the transmission to the P park or N neutral position. This positioning is vital, as certain safety protocols prevent starting the engine unless it is in one of these positions. Using the HDS, you will check specific parameters related to the starter cut relay control signals. The current conditions should be compared against the specified thresholds to ensure they are within acceptable ranges. If the current conditions meet the thresholds, proceed to the next troubleshooting step, as this signifies that the relay may be functioning correctly. Conversely, if the conditions do not match the threshold, further investigation into the starting system may be necessary. Step 5 focuses on determining the possible failure area of components like the PCM and others that may affect the starter cut relay. With the vehicle in the off lock mode, jump the SCS line with the HDS and wait over 1 minute before disconnecting the PCM connector A51P. You will then turn the vehicle to the on mode again and measure the voltage between two specified test points. One test point is pin number 4 on the PCM connector, while the second will be a body ground. It is essential to confirm whether battery voltage is present at this point. If battery voltage is found, the issue might lie with another component or an intermittent failure, prompting further investigation into authorized service information. Should no voltage be detected, the investigation will continue into other wiring aspects related to the DTC. In this sixth step, an open wire check will be conducted on the STRLY2 line. Similar to previous steps, begin by turning the vehicle to the off lock mode and ensure that starter cut relay 2 is disconnected from the fuse relay box. The focus now is on checking the continuity between two designated test points. Pin number 4 on starter cut relay 2 4P socket and pin number 4 on the PCM connector A51P. This test will help in determining if there is continuity, indicating that the STRLY2 wire is intact. If continuity is found, this suggests that the wiring is functional. If there is no continuity, however, it indicates an open circuit somewhere along the wire. This necessitates repairs to rectify the disconnection between the PCM and the starter cut relay to restore proper function. For Step 7, you will inspect fuse number C31, which is rated at 7.5 amps and located within the under-dash fuse relay box. This fuse plays a crucial role in protecting the starter cut relay circuit by preventing overloads that can lead to potential wiring damage. It's necessary to determine whether the fuse is intact, as a blown fuse could directly contribute to the low voltage issue described by DTC P16F4. If the fuse is found to be functional, you should proceed to Step 8. If the fuse is blown, however, check for shorts or breaks in the IG1 start cut wire, which runs between this fuse and the underhood fuse relay box, and make the necessary repairs. After fixing the fault, replacing the blown fuse is vital to restore proper circuit functionality. The final troubleshooting step involves an open wire check on the IG1 start cut line. To do this, start by disconnecting the under-dash fuse relay box connector E36P. Utilize a jumper wire to connect terminals A, number 10, and B, body ground. Once this jumper is in place, check for continuity between two specified test points: pin number 3 on the starter cut relay 2 4P socket and body ground. This test will indicate whether there is continuity in the IG1 start cut wire. If the wire is intact and functioning, the replacement of the under-dash fuse relay box may be necessary to resolve the issue. If continuity is absent, this points to perhaps an open circuit which needs to be addressed by inspecting and repairing any breaks in the IG1 wire. Upon completing all necessary repairs based on the previous troubleshooting steps, it's crucial to perform a final verification of the repairs carried out. Start by ensuring all components are reconnected accurately, and then proceed to clear any DTCs with the Honda Diagnostic System, HDS. After clearing the DTCs, perform the engine starting check again to confirm that the engine starts reliably without any issues. If the vehicle starts successfully, this indicates that the repairs were effective in addressing the DTC P16F4. It's also advisable to monitor the system for any recurring issues or codes that may arise, ensuring that the system remains functional and that all repairs have resolved the low voltage condition in the starter cut relay circuit. Preventive maintenance is crucial for avoiding the recurrence of issues associated with DTC P16F4. One of the most effective strategies is to conduct regular inspections of the electrical circuits, especially those associated with the starter system. This practice can help in early detection of any potential problems, such as corroded or loose connections that could lead to low voltage conditions. In addition, routine maintenance of connectors, including cleaning and applying dielectric grease, can enhance connectivity and prevent moisture ingress that may result in electrical faults. Ensuring that the fuses are functioning well and periodically checking for frayed wires will also contribute to a more reliable starter system. By implementing these preventive measures, vehicle owners can maintain optimal performance and extend the lifespan of the starter-related components. In summary, understanding Diagnostic Trouble Code P16F4 is critical for effective troubleshooting and repair of the starter cut relay 2 control circuit issues. Knowing the symptoms, possible causes, and structured troubleshooting steps enables mechanics to efficiently diagnose and fix low-voltage conditions. Following the steps methodically helps in isolating components such as the starter cut relay and the PCM, ensuring a thorough examination of the wiring and electrical connections involved. Proper verification of repairs and preventive maintenance practices can protect against similar issues in the future. By adhering to these guidelines, Honda Pilot owners can ensure their vehicles start reliably and experience fewer starting issues overall. Please like and subscribe to the channel. See you next time.